All right, so here's what we're gonna do today. This is chapter 10, so we're gonna actually pick back up working on putting azimuths online. We're gonna completely do a problem from beginning to end. When I say beginning to end, the first thing is we're gonna have a drawing that kind of looks like this, where I've got distances, and then I'll give you one bearing, and then I'll have you compute the azimuths, and we'll start plugging them in the chart. So first step will be adjusting our angles. So I'll give you your angles. We're going to total them up. We're going to find out how much we're off. It'll be an even, really simple number to where when we divide it by our setups, this is going to mathematically work. So we're going to do that. Once we get the adjusted angles, we'll then do preliminary azimuths. Once we do our preliminary azimuths, we're going to put it in our chart, just like that. So I'll give everybody a chart. So that's as far as you got on your own for the ones that you did around the building. Then we're going to pick up and we're going to complete out the rest of this chart. And then the last step is going to be like adjustments to our X and Y. So it's going to be like a process that we're going to go through. So I don't think I'm going to have enough real estate room on this board to put like this up. I may have to use the whiteboard to get here. So I can start off with using the sharp. Oh, I'm not even sharing the screen, so. So let me go back. All right, there's somebody at home. Oh, no. Who's that? Chris. Okay, so Chris is home. So this is where we're going to start. We're going to I'm going to draw that for you. I'm going to give you your angles first. So step one, if you look at the beginning of chapter 10, and you look at the steps, step one, and I'm like the second paragraph says, adjust angles or directions to a fixed geometry. Step two would determine preliminary azimuths or bearings. Step three, calculating departures and latitudes and adjust them for misclosure. And then step four would be computing azimuths of the traverse lines and adjustments. So this is where we're going to start. Today, I need to set an alarm. I've got to probably be out of here quarter till 12. Because I got a meeting I've got to be logged into. I don't know if I'll have any problems. So I'll let y'all kind of take, if you need to take a break, take a break. But I'm going to try to do a step process with you. So we're gonna get started. So the first thing I'm gonna do is I'm gonna put the angles for you. So get your calculator out. Everybody needs to get one of the charts here. Everybody can get a chart.
So this chart right here, you just start a new one?
We're going to start a brand new one.
Okay.
We're going to go from beginning to end.
Thanks, brother.
Mess up something.
I think it should mess up.
What module is this one in? 5.
You need a 3D.
So I'm going to start with the angles. So we're not ready to put it in the chart first, because we've got this means measured angle. So once I write the angles down, I'm going to get out of the way.
These are the preliminary algebras.
So no, these are the angles. So these are the angles. So step 1 is going to be, we're going to need to add it up, add all the angles up. If it's a 5-sided traverse, what should our angles be? Remember, number of sides minus 2 times 180. So 5 minus 2. I think that's 540, isn't it? 540 degrees. All right. So what I need you to do, make sure you can read all my numbers. And I want you to total them all up for me. So that's the very first step, is that you would be given the angles. And we've got to put them to a fixed geometry. Make sure I'm recording. Yeah, it looks like I am. So. So can y'all read all the numbers? You want to write them down and you want to total them up for me.
Do we need to round it up?
Round what up?
Like, you remember yesterday on the question that said simplify?
Mm-hmm.
Like, we do the same thing.
Add them by hand.
Oh, okay.
So yeah, the one that was
That
simplified.
was 270, right?
Yeah,
Okay, so I just put 2
so simplify, like if you're adding these by hand and you did the 20 seconds to 55 seconds to 25 to 30 to 45, when you get that number, you're not gonna just leave it like that. You're gonna take out how many minutes and carry it over. So it wouldn't have been that 60 seconds, we would have left it. We would have took that 60 and put it into the minutes, which would have made that 60. And then, so it was either 270 or 180. It was one of those. So I normally, when it started getting like this, I just do them in the calculator. That way I can go ahead and, everybody know how to type it in your calculator. So somebody, I want you to give me the total.
I got 539 degrees, 59 minutes, and 55 seconds.
500 or 400? Oh, okay.
Yeah, 539.
Okay, so it would be 539, but I got a different amount of seconds.
How many seconds you said?
55.
Oh.
All right, somebody else get a second?
I got 55 as well.
Okay. Maybe this book is wrong. Make sure I wrote them all right. 55, 25. Oh, I did it wrong. Sorry. That'll work out. What happened is I wrote the last one wrong. This was supposed to be a 35, but I'm gonna leave it. Okay. Because we can adjust from that. So we're 5 seconds under.
Okay.
Because if I take 540, minus our 530, okay, so we want to adjust these equally. So we want to take your 5 seconds divided by your 5 setups. That would mean 1 second. Agreed? So if I add 1 second to each of those, then it should mathematically close. So however much you're off, and every one that we do from the textbook are going to be like an even amount where you're not having to have the surveyor get involved. So that means I need to add, because we're too low, I need to add . Adjusted angles. Make sure that let me fix it, because if not, I'm not going to get the same answer. Sorry. I already have it all worked out, so if I mess up, So that's the only thing I'm changing.
Why is that the only thing you're changing?
Because that's the one I wrote wrong. I actually have this already worked out, and I had wrote that on the board wrong. It was supposed to have been 35 seconds, and I wrote 45.
Oh.
I looked
Well,
down,
it's still at 8 equals 548.
so it's actually 15 seconds off. So what happened is I looked at my summation, and I looked at that 45 there and used that.
So the last one was 35.
Yeah, that was my fault. So now, if I subtract that, so it's going to be 15 seconds off. Okay, we got 5 setups,
So we need to add 3 seconds.
so we need to add 3 seconds. Yes, thank you. So the first one would be 36 degrees, 44 minutes, 23 seconds. So you want to add 3 seconds to all of these.
You said not one.
No, 3 seconds, not 1. I wrote something wrong on the board earlier. What is that noise?
Someone's falling in the hallway.
I'm gonna move out of the way in just a second. It was in the hallway?
Yes,
Or somebody's phone? All right, so I'm gonna move out of the way in just a second. And then I'll answer questions. All right, tell me you had a question.
I had, I just corrected the left part.
That 35 is the one I messed up on.
Yeah, I just corrected it, and it equals 540.
So you add 3 seconds. Does everybody get the adjusted? That one's kind of, you can do that math in your head. So I'm gonna make sure that adds up. 44, 23, 58. I'm ready to get y'all back outside. So yesterday, we were outside and we went to Spring Lake campus. We're doing 17 acres out there. And it's mostly open. So I took both bipods because our traverse points are like 800 feet away. So that far. So, and they had to walk the whole thing. Typically, I used to could drop them off, but we're not, actually I don't take the van, so I'm having to load stuff up in my car. And we're going out there, there's 9 of us, and I don't want anybody to get in the car, my car for you to drop us. So everything was walked, they had to walk everything. But then we also tried to make everything fun out there, because if you can't have a good time when you're outside working, that makes, dull, very dull. So to begin with, the first person that ran the instrument had like Louise had a hat on. So they were putting acorns in, like kind of like have you ever seen the jokesters that are on part of PBS or I think it's where the guys try to embarrass each other.
The practical joke.
Yeah, practical joker. So they were putting acorns in there and he never felt it. They were putting them in and I'm showing him how to set the instrument up. Oh, well, they tried to get me killed, so they were doing that. So in the end, when he never felt a thing. In the end, when he went to put the instrument in and he leaned over, all the acorns came out and fell into the box. So he did let a cuss word fly.
What the what?
Yeah, that they were messing with him. So then the next setup we're looking at is 800 feet. So one of the guys was on the instrument and we were getting a backside. So you really couldn't see what the person was doing on the backside until you looked through the instrument. So it was Dylan. He had all this energy. He's sitting there doing the Macarena over there. Y'all probably don't even know what that dance is. I'm surprised he knew what the dance is. But what happens is Mike looked through there and he didn't even notice that that's what he was doing. I looked behind him just to make sure he was lined up. I was like, man, he's got a lot of energy. I said, are they not practicing? Because he had all this extra energy. He was like, he'll get this extra energy. I was like, yeah, he had it last week. They're like, oh yeah, I was supposed to. So he told about he was supposed to have a meeting yesterday. So he missed the meeting yesterday because we're out there at Spring Lake doing our final project. So so he was just seeing if anybody would notice it. So I noticed it, so I said something to all the students, and they're like, oh yeah, they got a new coach. So I'm not gonna go into all that with them recording. So that was that. Later on, so you know how I had that little stool that I have, that I pulled out and so I've still been sick again with my kidneys, so I had that. Somehow, they found an old, like, Mad Dog 2020 empty bottle out there. It was like a small one. Does anybody know what that is? Some old, like, rock gut wine. And they were sliding it under my seat.
Take a picture.
And I never even saw it. And then I was like, yeah, that wouldn't be too good. I get home and try to explain to my husband why I've got Mad Dog 2020 folded up in my, I'm not sure who, but so in other words, it was like, and then every time we had a problem, we blamed it on one student. So the whole day long, everything that went wrong, it was Paul's fault. So of course, like I said, all day long, but then I told him the story about the Mad Dog 2020. And so I was like, yeah, back when I went to college, we'd mix it in with Richard's Wild Irish Rose and Hawaiian Punch. So they got a kick out of that. So y'all brought back like old memories 35 years ago of drinking that mess and mixing it with Hawaiian Punch. So that was like really cheap rock gut stuff. So, but they took it out. They did take it out, and that's how I know they did it. But I wasn't in there. There was like a little pouch in there, and they had already slid it in there without me feeling it or knowing it. So yesterday was kind of a fun day. Now, if we do have walkie-talkies, I'll say this. So one of my students, this happened to her dad. He's a surveyor, and they were surveying where the Waffle House is by the Skybow Walmart. There's that Waffle House out there now.
There used to be.
Did they get rid of that one?
Well, maybe it's still there.
So it's the one like in the out parcel, like right there near the Walmart. So they were talking back and forth to each other on the radios. And like I said, he told me this story, so it's not hearsay. And, typically when we're on the radios, we'll be talking back and forth, just like, did you see that crazy so-and-so? You're just making small talk, over the radio. So they're making small talk. One of them about got ran over, so he's cussing. Needless to say, the manager came out and asked them to control their language because somehow it was getting on the PA system in there. That is a true story. So I don't know how that happened, but their radios were transmitting to the Walmart, and the guy came out. So like I said, he his daughter actually she actually went through the program too, but he actually told us that happened. So not hearsay. So you gotta, we try to make fun, but of course, then it gets kind of, surveying's supposed to be fun. Just don't tell people around the campus you're taking yearbook photos and then try to get them to pose for pictures. My students have done that too. All right, so we've got our adjusted angles. So now what I'm gonna do is I'm gonna give you I'm gonna draw it up and I'm gonna write the angles in and I'm gonna give you one preliminary, I'm gonna give you one bearing where you can make it an azimuth and we're gonna go around. So when we're doing, and like I said, we're gonna get our preliminary azimuths next. All right. So I'm not gonna be quite perfect because I don't have my I'm going to go ahead and put my distances on the lines too. So once I get out of the way, I'll have you sketch it. I'll make sure I wrote my numbers right. Yeah. These are distances. I'm just going ahead and put them on there so you have them to put them in your chart. All right, so I gave you 615 less 189.53, 175.18 for the next 197, 42.39. Okay. So now I need to put my adjusted angles, the adjusted ones in here. For angle B, yours was 215.
44, 51 minutes.
Mm-hmm.
And 58.
Oh man, I have to be really. 51.
51 minutes, 58 seconds.
Okay. C. I'm gonna write that off to the side. That's 51 degrees.
Yes.
So this is gonna kind of be a recap of what was on the test, kind of. I got all the angles written right, the corrected one, 36, 215, 51, 40, 28, 111. Alright, so I think I've got. So if we go from A to B, B to C, C to D, we're going clockwise. So remember from chapter 7? Chapter 7, we did those preliminary azimuths in chapter 7, computing azimuths, page 171. We actually did, we actually worked with page 165, we did A and B. If we go in a clockwise, we're going to subtract. If you go in a counterclockwise, you would add. So the example we did was on like 172, that's that table 72A. We added the angles. When you did your big traverse around the building, if we went in a clockwise, you subtracted them. Okay, so you ready to us to do those? Okay, so what I'm going to do is I'm going to go ahead and convert that 6 degrees 15 minutes west to an azimuth. So somebody give me the azimuth from A to B. If it's in quadrant 3, how do I, remember your chart? This is kind of what your test was on. How do I convert that to a?
So we would add 180?
We would add 180. Yeah. So that would be 186 degrees, 15 minutes. There was no seconds. So I'm put.
That's side BA or AB.
That's the bearing from A to B.
So we, like on the chart, it'd be AB preliminary azimuth.
Oh, 36.44.
So we're not ready to do the chart yet.
Oh, sorry.
Okay, good. So I'm glad you asked that. So we're not quite ready to do the chart yet.
Because it's in quadrant, we would add 180.
But eventually, yeah, I'll highlight the ones. That would be what would, that one particularly would go in the chart.
Okay.
All right, so I'm gonna like maybe star that one.
So A to B is 186.15.
Yeah, because we just added this 6 degrees, 15 minutes.
Okay. I messed up. I wrote that 56.
Yeah, I'm not gonna say nothing because I put the wrong.
I wrote that 56 or something.
Yeah, that's kind of looks up.
All right, how do I get the back azimuth for B to A?
So it's greater than 180, so we subtract minus 8.
Okay, so it's greater than 180. So I'm now back at my 6 degrees, 15. Okay, so my first angle for B, and I think some of you asked me this too, is 215 degrees, 51 minutes, 58 seconds. Can we subtract that? No, because it would be a negative. So what do I have to do? 360. So I'm going to go ahead and add. So when you add them, it's pretty easy. It's when you subtract them that'll. So, and now I'm going to subtract B. And let me know what you get. These things are almost indestructible.
I got 150 degrees, 23 minutes and 2 seconds.
Yep.
Thanks for that one. What'd you get?
150 degrees, 23 minutes and 2 seconds.
How many seconds?
2.
How many minutes?
23.
Just make sure it works. In 2 seconds. That would be. All right, so I'm gonna write it up here, and I'm gonna use a different color. You had 150 degrees.
23 minutes and 2 seconds.
So that's the azimuth from B to C. So we're going to need to know that. If you want to go ahead and plug that into your chart, your first one would be this one. So the first line on the chart, you can put side A to B and write the 186.15. Then you can go down, next one would be B to C, and you can go ahead and put 150.23.02. So you can put it in your chart if you want to.
And this would be azimuth.
Yeah, so that's going to be the preliminary azimuth from B to C. All right, so we're going to move on. So my next one, is that greater? So I need to do the back azimuth. So is that greater than 180 or less than 180? So it's less, so I'll need to add 180, and I'm not going to use green.
Makes sense till we see it on test, yeah.
Pretty much. I love it.
Did I add that right?
Is that 330?
Yeah.
Okay.
And so that's back azimuth C to B. And I'm ready now to subtract angle C. And I'm gonna have to go to the next chart. So actually what you're solving for will be C to D.
Subtract the one.
So you're gonna subtract, you're gonna take the back azimuth minus your angle, so you're right here. And that'll give you the azimuth from C to D. So I'm gonna have to kind of flip back between these. Like I said, I knew there won't be enough real estate room. So when somebody gets it, call it out to me.
278.
What do you have?
278 degree margin of maintenance and 34 seconds.
Do I get a second?
Yes, sir.
Okay. So we want that one in green, because I'll need, you can go ahead and put that in your chart for C to D.
That's great.
Okay, so I'm gonna flip back over. So before I flip back over, I want to know what is that greater than 180 or mine is less than 180?
Great.
So I need to subtract 180. $98, $42, $34. Somebody check that, make sure I did my math
Yep.
right. All right, so that's back azimuth from D to C. So I'm gonna just flip back over here. And now we want to subtract the 111.0633.
Subtract it.
Aren't we subtracting all of our angles? So can you subtract that?
Wait, or yeah, you can, because I guess we can have a negative anyway.
Nope, we can't.
So then, no,
So what do we gotta do?
add.
And that's angle D.
Seven, six.
That's D to E.
DD. Somebody check my math.
Yep, that's right.
Double check with me.
Ma'am,
Mm-hmm.
when did you use the angle this time to get, the
The
E?
We-
111?
You used the D angle?
Yeah, because I'm at that point now. So, back up, so when we were here, we subtracted angle B. So we started here, we subtracted angle B, and it got us the bearing from B to C. And then we've got to subtract C to get C to D, and to get D to E, so you're subtracting every angle will be subtracted because we're going clockwise.
Okay. All right,
That answer.
yes, ma'am.
So again, 3 weeks ago, I think I said this is the hardest subject to get. You get through this, because once we plug it in the chart, it's just crunching numbers. You can get through this, and to me, it was the hardest to comprehend when I was in your shoes. It's not a complete, absolute formula that you can see and you can plug and chug. Because you have to think, am I going clockwise? Am I going counterclockwise? Do I add 180? Do I have to add 362 of that? So, I mean, I'm just saying, it's probably checking one thing real quick, make sure I'm on tap. Okay, so we're perfect so far. All right, so greater than 180 or less than 180? So I need to get the back azimuth. So subtract one, oh, I don't want to do that in red. So you can go ahead and write this D to E in your chart. 347 degrees, 36 minutes, 01 seconds. Go ahead and write it in your chart. So now I need to subtract 180 from that. So I'm going to go ahead and come up to the top. Okay, did I do that right?
It's 167.
Yeah, 160.
Yeah, because that would be a 2. So that would be, so that's your back azimuth from E to D. So I'm going to flip back over. And so we just got the back azimuth from D to E, and now our next angle is 124.36, 38. So the next one, I'm gonna subtract out angle E. And that's gonna give you E to A. When you get it, let me know.
42 degrees, 59 minutes, and 23 seconds.
Yeah. 42 degrees.
59. 23. 23.
Bingo. So you can go ahead and put that in on your last line. So you should have Now, A to B, so this one actually needed to be circled in green. So we got A to B from, now I want to check it. We got A to B, B to C. So A to B would be 186.15. B to C is 150, 2302. C to D is 278 degrees, 42 minutes, 34 seconds. D to E is 347 degrees, 36 minutes, and 01 seconds. And the last one, E to A, is 42 degrees, 59 minutes, 23 seconds. So we don't want to just leave it there, we're done, but I would suggest, what do I have on page 1? Oh, that was my angles. I would suggest let's tie back in and see how we come to this last one. See if we get that 186.15.
CD again? 278? What's the one before that? I got that one. 330.
So I wouldn't just leave it. So I'm gonna check back and see if we get exactly what we start with. So anybody that needs to like get up, stretch, but I gotta kind of keep moving since I got a knock off. But
So we got 1, 2, 3, 4. Let's put the fifth one. That one. 42 degrees.
Mhm. So I'm just doing a check now. So this last one I'm just gonna write as a check. Greater than 180 or less than 180? 42. So we want to add 180 to it. So this is just a check. So if I do this, do it in the calculator for me. Because if I'm doing it by hand, then I'll have to.
186.15.
Okay. Is that what we started with? All right. So we're good. We are cooking.
Cooking with fire.
Yep, really good. So y'all on fire. So you say you do it great in the classroom when test time's come, you like blank on it?
Pretty much.
A lot of people do that. I'm not gonna say I don't do it.
Yeah, I don't know what, it's like one number mixed up and the whole thing messed up.
Yes, it does. Yeah, it does. You can work, but I mean, I've gotten on a math test and do all the homework, got it all down pat, and I get in there for test time and I just draw a blank.
Right.
Thinking, man, I knew all of this last night. Why don't I know it today?
Test anxiety.
Yeah, so I think. Which I take, I'm a good test taker. So when I was doing the standardized testing for surveying and engineering,
I'm good with multiple choice.
There we go.
Well, that's those are multiple choice, not the second part of the second part of the state was, erosion control was not, so I had to show numbers. All right, so now I'm ready to plug the distances in. Let me see, because I'm ready to get, so you've already, I'm ready to start. So actually ours is going to be like A to B, B to C, not how they have stations. I don't think that I can get this all. Y'all don't use that. You don't use the board at night in CAD, do you? Okay. So let me do that. Let me see if I can kind of turn this around and I'll start. Okay, so I am recording. Let me just go back and show the screen and I'm going to start on the board. So hopefully you'll be able to see the board once I turn it that way. I don't want just for it to be in your way. Okay, can you see the board? Good.
You can see most of the board. Whole board is in view.
So probably the best I'm gonna get without, because I got. Should I go out a little? Can you even see this? Am I in your way?
Just put on the screen.
Okay. Yeah, it might be hard to see the screen. Okay. All right, so what I'm gonna do is start here, far left. So we're doing it from beginning to end. So I'm taking you through the complete. All right, A to B azimuth. Somebody give it to me. Is it 186?
186 degrees, 15 minutes, and 0 seconds.
Okay, B to C.
150 degrees, 23 minutes, and 2 seconds.
Okay, C to D.
278 degrees, 42 minutes, 34 seconds.
Okay, D to E.
347 degrees.
347.
347.
327.
47.
Oh, I had it right. 347.
Yeah.
Okay.
36 minutes and 1 second.
And last one, E to A.
42 degrees, 59 minutes, and 23 seconds.
All right, so now I need to put my distances in the next column. So That next column is length. And that's what I had on the first page, but I'll go ahead and give them to you. I'm gonna write them. So this one's 189.53. So in your chart, actually I have latitude, which is your X, measure Y. These are unadjusted. This is probably as far as we'll get today. All right, so azimuth distances, I went ahead and summed them up. And the next column is latitudes and departures. So the formula's up there. It's your length of your line times the cosine of the azimuth for latitude. For the departure, it's the length of the line times the sine of the azimuth. So actually your latitudes are your y. I probably should have, I think somebody, one of the students had made this. And I probably would have flipped them out. So we are actually, if you're following, we're actually back in chapter 10 again. And we're right using the two formulas, and I've got them on the chart. They're on page 244. So it's equation 10.1 and 10.2.
Carry them out to like 4.
I would. And the reason I carry them out to 4 is because your degrees, minutes, and seconds is,
Can't see it on the big screen.
they kept it up to 3.
Slow set.
You can't even see that from that far away, can you? Let's, well, if I do that, then I'm blocking the whole class. Gotta be able to see it. Let me just attach it. I think you're gonna.
You could put the camera on top of your
Yeah, like on the dash.
bag and let it handle.
It might make it easier.
Okay, so I can do. I got a fix for it. So there's only one USB in this whole thing right here. And so last night, I put I said I asked for a splitter when I got the camera and the microphone. So I'm getting ready to lose this for a second. Well, I hope you got it in.
Is the extension properly connected?
Yeah, it actually's got the,
So it just doesn't want to work.
yeah, I think it's got a, all right. Now. Just lost everybody's. All right, so let me go back. So sound, I got sound now again. So what I'm gonna do is just do my whiteboard. I'm just gonna put it on the whiteboard. You can see my screen? Okay. So you asked how many decimal places, and I said 4, which is fine. Okay. So the next column is lats. These are, and then next column is departure. Okay. So the formula for latitudes is L. I'm gonna write it up. Is L times cosine the azimuth, which is your length. That's my latitude one. And the departure one is L times the sine of the azimuth. All right. This is about probably where we're going to get to today. So these are going to be unadjusted. This is the next column. So an example, I'm going to take 189.53 for, I'm going to do the latitude of the first one, times the cosine of your azimuth, 186 degrees, 15. And you want to keep your sign. So if it's a negative, you'll put a negative. If it's a positive, you'll put a positive. So, so I got a negative 188.403, and it would round up to 5, correct?
Yes.
Okay. Who wants to give me the next one? B to C.
Says negative 152.2928. 38.
38?
Yes, ma'am.
Okay. Who's got the next one?
9.9486.
And I've got,
486.
okay, next one.
139.0685.
So, okay. And last one.
171.5896.
Do I get a check from somebody?
Yeah, those are all straight.
So we want to make, you can do it in your calculator. All right. I'm just making room underneath here. My summation of my distances, I'm going to write that here. Okay, when you sum these, it's probably going to be a negative number.
Negative 0.0906. 906.
That's not the error, right?
That's your error of your latitudes. Adjusted. Yeah, so that's actually your latitude misclosure.
May
Okay.
you write down the equation you used to get that point or not?
This one,
Oh, yeah.
just total this column up. You add all these together. So you added everything in that column. So that's why I got like a summation. That's what that symbol is supposed to be. So that means you add them all. You sum. I'm going to take. What was the last two numbers?
0906.
Okay. All right, so let's go ahead and put the departures in. Anybody started on the departures?
Negative 20.6335.
Negative 20.6. Okay.
86.5716.
Okay.
Negative 195.4994.
Negative 30.
Negative 30.5755. And 159.9524.
Okay, so I'm going to do the same thing. I'm going to do a summation of that. When you add that column up here.
I got negative 0.1844.
Now I know we kind of sped along, so make sure your calculator, you can at least get these numbers. All right. So I'm going to look at page 245, and I want to solve linear misclosure and relative precision. So it's on your chart, kind of at the bottom, formulas. So I'm going to do linear misclosure. That'll be the square root of, no, we've got it, departures first. It doesn't matter. So that formula is your square root of your departure misclosure squared plus latitude misclosure squared. If you get something like, I'm gonna write the answer over here.
Like 2054549099.
Oh, now, got it all the way out. So when I get here, and I've already got it in my calculator, that relative precision is, that's my next one. Relative precision is the linear misclosure divided by your traverse length. Okay, but that's going to give you like a really, really small number. So really the definition, it's the fraction result, and then we're going to reduce it to a reciprocal form. So if I take that number, 0.20, turn my calculator on. I'm getting something like 0.00021369 like an e to the minus 4. You're going to hit the x to the minus 1 because that'll give you the reciprocal. And now I have 4,572.
Do we keep the decimal or no?
No, you just drop. So you at this number, this is called your relative precision. It's 1 over. You just drop the decimal place. Don't round on this one, you're just going to do the number to the lowest one. Now, if you do the formula the way the book has it, you have to do the reciprocal form. You got to do the x to the minus 1 once you divide it. When I'm out in the field and I'm trying to figure that out, a lot of times I'll take that 90, I'll take the bigger number, my distance. So if I say 939.46 and divide that misclosure, that 0.205454909, I'm going to get 4572 as well. So it's going to be a big number. Don't give me like a real negative small number. You'll know something's wrong. So it's going to be a big number. So typically, do y'all remember what number we should have? what numbers should you have there if you're doing based off, surveying standards here?
Over 10, under 10,000.
So it needs to be 1 to 10,000.
Oh, 1 to 10,000.
So when you did yours outside, y'all came in at, I know you had over 10,000 when you did your misclosure for your traverse around the building. That group had like, well, I think we redid it a couple times. What was your precision? You guys were like 1 to 9,000 and something.
Yeah.
And I said, I'm okay, I'm not gonna make you go back out for that. How much? So they're at 1 to 11,000 and something, so this one you really would not even try to adjust, but we are gonna adjust. So this is just kind of a review to this point. So tomorrow, we'll do our adjustments, we'll balance them, and we'll get our coordinates. So we'll be working basically out. I'm gonna save this. I'll save it as a PDF too.
Make it a little bit neater than